All right, today we're starting a new chapter, and we're starting with simple motion, also called rectilinear motion. Yes, it sounds horrible and funny, so laugh now. Or straight line motion is kind of what that means. And I wrote a bunch of the notes up so you wouldn't have to take your time to write them all out yourself. Just make sure you know them. S at T is typically what the letters that they usually use, and that's our position function. It tells you where. What is this?
This one's like complicated.
Oh, I'm sorry. Here. Right there. That kind of tells you where the object is at any given point in time. The velocity function, we get our velocity by taking the derivative of S of t, and that's how we get our velocity. The acceleration function is the second derivative of S, or the derivative of v, and we call it a at t. Notice, up until now, you've used speed and velocity interchangeably. We've kind of used that word to kind of mean both things, and it's been fine up until today. Actually, speed is always positive. It doesn't matter which direction you're going, speed is always positive when we're talking about speed. So speed is actually the absolute value of velocity. Velocity can be positive or negative, and it also tells you direction, not just the rate, but direction. So it says that going right or up is a positive velocity, and going left or down is going to be a negative velocity. Remember, velocity is the rate at which a position or the distance changes. When you tell somebody that you're driving your car at 90 miles an hour, number one, shame on you, and number two, you're going 90 miles an hour, your position is changing at that rate. So that's what you're talking about. Acceleration is the rate at which the velocity changes. So here's our example. If the position of an object is, and they give you the equation here, then find the velocity and acceleration of the object where distance is measured in meters and time is measured in seconds. They just wanted the velocity and acceleration. Well, we just learned velocity is what? How do I get it? Derivative. So let's take the derivative of the equation, and we're going to get 9t squared minus 81t plus 162. Questions? That's it for velocity. Very simple. Acceleration, let's find the derivative of velocity. So 18t minus 81. So far, so good? Next, what is the velocity when the object changes direction? Now think about this. Picture yourself back in field day, elementary school, you know, you guys had to do like all these different events, and one of them was like the relay race. You'd get together with your friends, you guys would have a team, and you'd do a relay, and you'd run to the end and touch a line and come all the way back. At the point where that kid goes down and touches the line, what's his speed when he touches the line?
0.
0, because he's changing direction. So we put a 0 here. I'm very sure about that. It is 0. He is correct. When that kid goes in and touches that line before he turns around, right at that point, he has no speed. He has stopped and he's turning directions. So 0. We're going to go ahead and type in these three functions into our graphing calculator so we can kind of see the picture of the graphs. Let's go ahead and put the position function in first for y sub 1. So I have 3x cubed minus 40.5x squared plus 162x. The second one is our velocity function, and it's 9x squared minus 81x plus 162. And then the last one is our acceleration function, which is 18x minus 81. And I'm actually going to fix my window because I know that I need to. I'm going to do... You might think about changing your window to this, because I just know you're going to need to. For your x, min, and max, I would do -1 to 10. We're talking about time, typically. I mean, we can't really go back in time, so let's just start kind of close to 0. Maximum, let's just look at 10 seconds out. For the y minimum and the y maximum, let's go -200 to +200. And I changed my scale to 20, so I don't have like 400 of those little lines. And then we hit graph. Bless you, bless you. Position function comes in first. Oh crap, I think I typed it in wrong. I do not remember it looking like that.
Does it look like 2 thirds?
Yeah, mine looks like that.
Oh, it's because I changed the equation after first hour. Shoot, I need to fix my window. Sorry, I forgot what I did. Let's fix this. It needs to be a little taller. I'm going to go negative 100 to 400. Did I type it in wrong? That's correct, right? Yeah. Okay, let's leave that at that and see what comes in now. I did? Crap. And now I have to wait. It's going to take forever. These fancy color ones are great, but they take a long time to graph. Well, does that work?
Yeah.
Really? That doesn't mess it up? Okay. Okay, what did I type in wrong? Oh. Wait.
It's 81.
Yeah.
That's 81. Thank you. Okay, let's try that now. Thank you. For my window and my x value, I did negative 1 to 10. And for the y values, I did negative 100 to 400. Okay, so here's what we have going on. So if the first one is the position function, think about where the horizontal tangent lines are going to be. It's where it changes direction, right? Right here at that peak and right there at that valley. So if that velocity, that speed is 0 and that kid changes direction, then the velocity, the red one, is going to cross at 0, and it does. Do you guys see that? Crosses at 0 in 2 places. And that kind of makes sense. So graphically, you can kind of see the derivatives, which is kind of nice. Now it says, where is the velocity 0? We can figure this out mathematically. We're just going to say 0 is the velocity for this function, and we just set the function equal to 0. So let's factor, because it's one of those quadratic ones, and we can factor 9 out of this to make this a little easier. So we have t squared minus 9t plus 18, I believe. Then you can factor further. The t minus 6 and t minus 3, and they're both negative there. So that t is going to be 3 and 6, and it's at 3 seconds and 6 seconds that this object changes direction. So it's at 3 seconds and 6 seconds. Yes, sir. You do nothing with it. It doesn't affect it. Okay, so it's at 3 seconds and 6 seconds. Then the question says, when is the object moving right and when is it moving left? Now, we can tell from our graph, the first one, the blue one, if the position is it's headed to the right or up or whatever, and then changes direction and it changes direction, it's at those places that we just figured out where the velocity is 0 is where it changes direction. Now, here's the thing, is figuring out the right and the left, and here's what you have to do. You're going to write yourself a little number line off to the side. And I know that it changes directions at 3 seconds and 6 seconds. You've got to figure out which way it's going when. Because maybe you're not going to be able to graph it. Maybe you just have to know by looking at numbers. So we're going to plug a number in that's to the left of 3, an easy one like 0. If I put a 0 into this equation, I get 162, and that's obviously a positive number. So that's positive values. A number between 3 and 6 that would be easy might be like a 5. If I plug it, I'm going to plug it into this bottom one to make it easy. 5 minus 6 is a negative number. 5 minus 3 is a positive number. So I have positive times positive is going to give me a negative answer. And then if I take a number larger than 6, like 10, and plug it in, 10 minus 6 is a positive. 10 minus 3 is a positive. So I have positive times positive. That is a positive answer. So if it says, when is the object moving right, it's where you see the positives. So it's from negative infinity up until 3. Now, why do I put a parenthesis? Why don't I put a bracket on 3? Right, because it's changing. So right at 3, our velocity is 0, and it's switching directions. So it's not really moving right or left. And it moves right again starting at 6 seconds to infinity, and it moves left from 3 to 6 seconds. Whoops, sorry. Questions on how I got those answers? Is everybody okay? All right, when is the object speeding up and when is it slowing down? And this is the tricky part because we use the word acceleration in one way, like in just our vernacular as we speak. In calculus and physics, it's kind of something different. So you have to be a little bit careful when you're thinking about acceleration. Here's how you're going to figure out this answer. Down here where this note is. Speed increases when velocity and acceleration have the same sign. Speed decreases, or it's slowing down, when the velocity and acceleration have the opposite sign. When forces work together, an object's going to speed up. When they're working against each other, it's going to slow down. So here's what we're going to do. We're going to take the acceleration equation and set it equal to 0 and find out where that acceleration is going to change. Oops, I did it again. I'm transposing my numbers. I'm sorry, that's an 81. Goodness gracious. So you should get 4.5 for T on that one. So here's what we're going to do. See your number line? Right underneath it, you're going to draw a number line for acceleration. And 4.5 falls exactly halfway between 3 and 6. So I'm going to put a divot right there, and that's my 4.5. Kind of want to line them up, and you're going to see why here in a minute. You go ahead and test each side. So if I put in a number to the left, like 0, if I put in a 0 here, I'm going to get a negative number, right? So those are all going to be negatives. If I put in a number to the right, like 10, I'm going to wind up with a positive number. Now here's how we match up our signs to see if we're speeding up or slowing down. I'm going to put a tall yellow line on each of my sort of critical points where either the velocity or the acceleration changes. All right, so check out these little guys right here. Up until 3 seconds, are the signs the same or different? Different, so is it speeding up or slowing down? Slowing down, so from negative infinity to 3, it's slowing down. The signs don't match. All right, let's look between 3 seconds and 4.5 seconds. The signs are the same, so it's speeding up from 3 to 4.5. And then something changes again. From 4.5 to 6, the signs don't match. The forces are working against each other, so it's slowing down. So we have from 4.5 to 6. And then from 6 to infinity, they're both moving in the same direction. They're helping each other out, and so it's speeding up. So we say 6 to infinity, working together. Questions on how to, yes ma'am?
So you did the second one. Is it always going to be negative 1.5?
I plugged in a 0, because that's on the left-hand side. 18 times 0 is 0, minus 81 is a negative. So you just test it. Okay? Other questions? Great. Okay. Last two things. Drawing a diagram for the motion for t at, and they tell you between 0 and 10 seconds. So here's what I would strongly suggest doing. You don't have to do it this way, but I think it's smart. We're going to make a little t-chart. And we're going to put in our sort of important times, which is 0 seconds and 10 seconds, because we're going 0 to 10, and we know that it changes direction at 3 seconds, and it changes direction at 6 seconds. Let's find out what position it is at those places. And you have a calculator, and it will do it for you. So if you hit second window, I'm going to put my table start at 0. Make sure for independent it says ask, because you're going to tell it what numbers you want. Hit second graph. I'm going to put in 0, 3, 6, and 10. And delete that guy out. Now, why do I have 3 different values for y? What's going on here? It's 3 different equations. Which one should I be looking at? The position function. The first one is the one I'm concerned with. So at time 0, it's at 0. It's at 0. When it's been 3 seconds, it's gone 202.5 meters. 202.5, or that's where it is anyway. At 6 seconds, we're at 162 meters. And at 10 seconds, it says we're at 570. Now, when it wants you to draw a diagram, here's what's tricky about this. If I go, and don't write this down, but if I start from 0, and I go 0 to 202.5, back to 162, and then up to 570, the problem with that is it looks like a straight line. It's not a very good diagram. So here's what we're going to do. The smallest number I have over here, the smallest position I have is 0, so I'm going to put a 0 at one end of the line. The largest number I have is a 570, so I'm just going to go out to like 600. So I have 100, 200, 300, 400, 500, 600. Here's how we're going to draw our diagram. This is t equals 0. We're at 0. Then it's going to go to 202, which is about here-ish. And that's supposed to be 202.5. And that's at t equals 3. And then, I'm sorry, what?
Is that 300?
Yes, that is a 300. That is not written very well. I apologize. There you go. And that's a 600 that also looks terrible. There you go. Zoom in a little bit. Okay, so I'm going to connect those two, and then it looks like it goes back to 162, which is like back this way. So that's 162, and that's at t equals 6. And then it goes all the way up to 570. So at t equals 10, we're at 570. And that's weird, but that's the diagram. So I've got the time as well as where it is, its position. Kind of. I mean, it's sort of estimated. Like if this is 100, this is 200, then 202 is a little bit bigger than that.
No, I mean like below the line.
Yeah. It doesn't matter how high or how low, but you need to have room to write. You know what I'm saying? And the reason, yeah, you can go up as long as I can tell what you're doing, sure. And the reason we didn't keep it on a line is because it would all just look like one big straight line. So we have to kind of space it out a little bit. They want to know the total distance the object traveled. That's what's next. Now, this was tricky for some folks first hour, and I know in previous years they've really struggled with this. Here's kind of a shortcut way to do that. You figure if you're going from position 0 to 202, how many meters, or how many, yeah, meters. How many meters have we gone? 202.5. So 202.5. Plus, how do I know how far I've gone from 202.5 to 162? Subtract. So grab your calculator and let's subtract. So 202.5 minus 162. I've gone 40.5 meters. Plus, how do I know how far I've gone from 162 to 570? Subtract. 570 minus 162. I've gone another 408 meters. Add them all up. You get 651, and they said that those are meters. So, questions on how to do anything on this page? Everybody okay? Flip your paper over. Your assignment is going to look a lot like this. You've got 4 or 5 problems, I think you're supposed to do, or 6, I don't know. It'll look like this. They're all the same questions we just did. Try to work ahead of me and do this whole page by yourself. I'm going to keep talking in case you need some help. Yo-yo's motion is modeled by, they give you an equation. They tell you that h is the height of the yo-yo in inches and t is time in seconds, and they tell you that only to work it for the interval 0 to 4. So this time we won't be dealing with negative infinity or positive infinity on any of our answers. We're only on the interval from 0 to 4. Velocity is the derivative of our position function. So I take the derivative and I get 3t squared minus 10t plus 3. Acceleration is the derivative of velocity. So I have 6t minus 10. And because this is my notes, maybe I'll make myself some notes so I don't forget tonight. This is first derivative. This is second derivative. And then it says, when is the object moving to the right? When is it moving to the left? I'm going to go ahead and make myself some notes so I don't forget. I'm going to set v at t equal to 0, and I'm going to test it on a number line. So I have 0 equals 3t squared minus 10t plus 3. That should be factorable, I'm hoping. Those are both negative, it does it. So I wind up with t is 1/3 and 3. Then you set up your number line because it's at those two times that the object or the yo-yo changes direction. So I've got 1/3 and 3. Now I need to test each section. Take a 0 and plug it in, and I'm going to get a positive number. If I take a number between these two, like say 1, and plug it in, 3 minus 10 is a negative. 7 plus 3, and that's going to be a negative. If I take a number bigger than 3, like say 10, and plug it in here, I'm going to get a positive. So when it says, when is the object moving to the right, it's where all the positives are. And I'm not going to say from negative infinity to 1/3. They gave me my interval before I even started. So I'm going to say 0 to 1/3. But here's the thing, I need to figure out whether to put brackets or parentheses here. Because I know that actually this goes back to negative infinity, but they said to start at 0, I'm going to put a bracket because it includes 0. At 0, it's still moving to the right. It's also moving to the right from 3 to, yes, infinity, but they said to just do it until 4. So I'm going to include 4 in that because it's still moving to the right at 4. Then it says, when is the object moving left? My negatives are between 1/3 and 3 seconds. So 1/3 to 3, and those are in parentheses. Next two questions. When is the object speeding up or slowing down? I'm going to make myself some notes so I don't forget tonight. I'm going to set the acceleration function equal to 0 and test on a number line. So the acceleration function, let's say 0 equals 6t minus 10. Add 10 to both sides. Divide both 6 by 6 and you get 5/3. I'm going to take 5/3. I'm going to set it up on a number line directly underneath this number line. And 5/3 is 2 2/3, and so we know it's halfway between 1/3 and 3. So there's 5/3 right there. And now I'm going to test each side. I'm going to put in a 0. When I put in a 0, I get a negative number. When I put in a larger number, like say 10, I get a positive number. Now to check speeding up and slowing down, I have to see when those signs match and when they are different. So visually, just to help me out, I'm going to draw some vertical lines everywhere the velocity or the acceleration changes. Now when I look from 0 to a third, the numbers are different, so it must be slowing down. So that would be, sorry, bracket 0 to 1/3. When I look from 1/3 to 5/3, the signs match, so it's speeding up. From 1/3 to 5/3. From 5/3 to 3 seconds, the signs don't match, so it's slowing down. So parentheses from 5/3 to 3 seconds. And then from 3 seconds to, remember, not infinity, but 4 seconds, the signs match, so it's speeding up. From 3 to exactly 4. It's at 4, it's still speeding up. Those are brackets. The next two questions, it says total distance traveled and draw a schematic. I kind of think it's easier to draw the diagram first. You don't have to, but I think I'm going to. And I'm going to use my little T-chart to help me get there. This is the height of the yo-yo. It wants to know from 0 to 4, and I know that it changes direction at 1/3 of a second and 3 seconds. So I'm just going to type that in my calculator. See what those answers are here. Let's see here. X cubed minus 5x squared plus 3x plus 40. I want 0, I want 1/3, I want 3, and I want 4. So it changed my values for me, so that the positions are at 40, and then 40.481, 31, and 36. So I took the equation, the original one, the position function, typed it in. I made sure that my table set was set to ask on independent, so that I could ask it what I wanted. I put in my 4 sort of critical turning points and got my position. My smallest number is 31, and my largest one is a little bigger than 40. So I'm going to go from 30 to 40 on a little line here. 30, 32, 34, 36, 38, 40. When t is 0, we start at 40. So t equals 0, we're at 40. And then it's going to advance a little bit to 40.481, and that's when t equals 1/3. Then it goes all the way back down to 31. And that's when t is 3 seconds. And then it loops around and goes back to 36, 246. So it's not pretty, but there you go. Oh, yes, sir.
For the diagram, should we try to space it out so that way, like, this would be like a 1/3, this is 3, or just kind of more?
It doesn't matter. It's just sort of a diagram, yeah. Because we're only really concerned with mostly the position. Yeah, good question. I'm not going to be really picky on it. So total distance, I'm going to look at how far it is from 40 to 40.481, which is 0.481. And the distance from 40.481 to 31. So I'm going to take 40.481 minus 31, and that is 9.481. Plus the distance between 31 and 36, which is 5. And add all those together. We got 14.962 inches. Okay, you guys that worked ahead, did you do okay? Is there going to be questions on any of this, or does it seem kind of doable? And I think as far as velocity and acceleration and what all that really means, I think it will all start to click in in the next few days. So if you don't get all of it today, that's fine. Alrighty, let me get your assignment.